All right. You may remember time not long ago when we did completing the square. Well, we're about to do it again. This time we're not graphing it. We're using it as a method of finding the solutions. We're finding those x-intercepts. So subtract 35 from both sides. You're always going to move that constant term over and leave some space. We are ready to complete the square. And so I'm going to rewrite this thing. Get ready to rewrite it as a plus or minus some number squared. The number that goes in there, remember, is just half of that middle term. So half of 12 is 6. 6 squared, so it's going to go up here, 36. We can't just add it to one side, we have to add it to both. So we do 36 on both sides. Negative 35 plus 36 is 1. Right? Now, to graph this, we moved the 1 over to the other side and we found the vertex. It does want us to find that vertex point. So that vertex point is at -6, -1. It's always the opposite of the number in the parentheses. And then if you move the 1 over, it would become negative as well. And because this is a positive quadratic, that means it opens up. So the vertex point is a minimum. But how do we solve it? We don't need to put anything into the quadratic formula. We just completed the square for the purpose of solving this. So what we do is take the square root of both sides, because the square root and the square are going to cancel out. And now we don't have that problem of having an a squared and an a. We just have a. So we have a plus 6 is equal to plus or minus the square root of 1. And the square root of 1 is 1. So then we will move over here. We'll subtract 6 from both sides. We get a equals plus or minus 1 minus 6. There's 2 answers to that. If you have 1 and you subtract 6, that would be -5. If you have -1 and you subtract 6, that would be -7. All right. Things are fixing to get complex up in here. So that's next. We're going to do some complex numbers. All right. We want to graph a complex number. Take a complex number off of a graph, but also find the modulus, which is just the distance of that point away from the origin. It's just using the Pythagorean theorem. So for the first one, -1 minus 5i, the -1 is the real part. And so on the real axis, we're going to find -1, which is right here. Wow. My thing freaked out a little bit. -1 is right here, and then -5i, this is the imaginary axis, traditionally the y-axis, -1, -2, -3, -4, -5. It's that point right down there. So that is that's the point. And then if we want to find the modulus, we do the -1 squared. Sorry if that was loud. -1 squared plus -5 squared equals the modulus squared. 1 squared is 1, plus 5 squared is 25. That's 26 is equal to z squared. Square root both sides. You get the modulus is equal to the square root of 26. That thing is the square root of 26 units away from the origin. I'll actually find out what that is. Square root 26, 5.1 about. Now let's divide some complex numbers. What we talked about was that we don't want an I in the denominator. So the way we get the I out of the denominator, if it's just negative 4I, all we have to do is multiply by I over I. In the numerator, what happens is we get negative 4I. In the denominator, we get negative 4I squared. The reason that's valuable is because I squared is negative 1. So what we really got is negative 4I over negative 4 times negative 1. Negative 4I over 4. Negative 4 over 4 is negative 1. So this is just negative 1I, or negative I, which is a lot more simple even for an imaginary number than negative 4 over negative 4I. Let's jump to 83 and then we'll do 84. 83 is very similar to 81, except that we have, we have a binomial in the top, 2 terms up there. So we're still going to multiply by I over I, which is different from what we're going to do on number 84, but we're going to multiply by I over I, and just note that the I has to be distributed to everything in that first set of parentheses. So it's negative 2I plus 10I squared, all divided by negative 6I squared. So we've got a lot of I squareds that we can simplify. Negative 2I, 10I squared, I squared is negative 1, so that becomes minus 10 over a positive 6. So the I squareds are just changing the sign of whatever number they're with. All right, now complex numbers are written in the form A plus BI. So the real part comes first and then the imaginary part. On this one, number 83, the real part is the negative 10 over 6. See if it'll circle that. The negative 10 over 6. Negative 10 over 6 is just negative 5 over 3. And then negative 2I over 6 is negative 1 over 3. And that is the imaginary part. So that's 83. All right, number 84 is where things get a little more complicated. This is where we have to multiply by this thing called the conjugate. Conjugate is the term for the result of changing the sign in between 2 terms of a binomial. So multiplying by 10 minus 3I. Can't tell you how many times I've seen people multiply by the same thing. It doesn't help. If you don't get rid of the I in the denominator, you're wasting your time. So the conjugate, change that sign and then multiply. So let's multiply the top first. 2 terms times 2 terms should get us 4 terms. Negative 1 times 10 is negative 10. Negative 1 times negative 3I is a positive 3I. Negative 2I times 10, negative 20I. And negative 2I times negative 3I is positive 6I squared. All of that is divided by 10 times 10 makes 100. 10 times negative 3I makes negative 30I. 3I times 10 makes a positive 30I. And 3I times negative 3I is negative 9I squared. So now I'll simplify the bottom of the fraction first, because this is what I was talking about. If you don't get rid of the i's, you're doing it wrong. So negative 30I plus 30I makes no more i's. It's crucial for this, what you're doing here. 100 minus 9I squared is just 100 plus 9, so it's 109. And then the numerator, negative 10, I'm going to skip these 2 I terms and go to the I squared. 6i squared is the same as minus 6. So this is negative 16. 3i minus 20i is negative 17i. I do not think that those simplify, but we are going to split them up anyway. So we'll do like 16 divided by 109. I hear my sad child in the other room. If I hit math, enter, enter, it gives me the same fraction I had already. So you can leave it as that fraction, or you could do negative 0.147 minus, and then what's 17 over 109. I do not believe that's going to simplify either. See, it gives us the same fraction back, so we'll do 0.156. There are our solutions. Next section, got to solve some quadratic equations, and you're supposed to sketch the solution on a complex number plane and calculate the modulus for the solution. And who made this? Whoever did this is mean. So let's do number 85. X squared. I'm going to move the negative 10x to the other side, because if you want to solve a quadratic, probably want it to be set equal to 0. So x squared plus 10x minus 20 equals 0. Now, if I could factor this, that's what I would want to do. I need factors of negative 20 that add up to 10. However, I do not think that such factors exist. So I'm going to complete this square. I think that makes the most sense for what I'm seeing right here. There's a one up here already. The middle number is an even number. So I think it's going to solve by completing the square pretty easily. I'm going to move the 20 to the other side, x squared plus 10x. I'm going to leave a little bit of space. And I'm ready to factor and complete this square. So I'm going to have x plus some number squared is equal to another number. Half of the middle number, half of 10, is a positive 5. So that's what goes in the parentheses. 5 squared is 25. And that's what I add to both sides. So this is going to be 45 over here. I'm going to square root both sides. And I get x plus 5 is equal to plus or minus the square root of 45. X equals negative 5 plus or minus the square root of 45. Square root of 45 is just a real number. So this thing isn't very complex at all. It's pretty real. Square root of 45 is 6.7. So one of my answers is negative 5 plus 6.7, which I believe is 1.7. And the other one is negative 5 minus 6.7, which is negative 11.7. That's a 7. And then if I were to draw a graph here, where this is the imaginary axis, this is the real axis, and I've got 1, 2. And then I've got negative 11.7 down here. So I'm just making up some points. And one in the negative direction is further. And then the modulus, so for this one, it is 11.7 units away from the origin. It's not a squared plus b squared equals c squared. There is no b squared. There's no imaginary portion. So that was just 11.7 units away. No more negative, just a number. And the net modulus for this one would be 1.7. Because it is also just on the real axis. There's no imaginary part.